Probability and Statistics 2, the November paper, the first variant. Let's get started. Question number 1. What is this question all about? It is known that the height of trees of a certain kind have a distribution such and such. So let me start underlining. That is normal distribution such and such. A scientist takes a random sample of 25 trees and finds that the sample mean h bar of the heights. The first thing is state the distribution of h bar. H bar follows a normal distribution. Mean remains as it is. Variance is divided by this n, where n is 25. So that is the first thing that is to be done. Next question, next part. It says find the probability h bar lies between 12 and 13. So therefore, probability h bar lies between 12 and 13. Standardize it. Probability z lies between 13 minus something over square root of something, 12 minus something over square root of something. So the mean is 12.5. The mean is 12.5 and the variance is 10.24 divided by 25. So that is 10.24 divided by 25. That is 10.24 divided by 25. Now over here, knowledge of S1 is assumed. That is basically about normal distribution. And let me just relocate this thing a little bit. So therefore, this is like this. Z lies between the two values. So this is like this and the z is somewhere in the middle. When we do the standardization and we do this thing, that is about changing it into z. So z lies between a positive value and a negative value. This is rule number 7 of this reading the table. Phi of the first value, phi of the second value minus 1, and then you end up with the answer. So that is the working for this particular part. So question number 1 is sampling, that's done. Question number 2. It says the mean number of inquiries received per day. So this is received per day at a customer service desk has a Poisson distribution with mean 45.2. If more than 60 inquiries are received, the customer service desk cannot deal with all of them. So it's about not dealing with all of them. It says use a suitable approximating distribution. So first of all, this question is about Poisson. So this is Poisson distribution and the approximation related to it. Use a suitable approximation, find the probability on a randomly chosen day, it's still a day. The customer service desk cannot deal with all the inquiries. So first of all, X follows a Poisson distribution with 45.2. Since lambda, the mean number of occurrences, is greater than 15, therefore X now follows a normal distribution. It's an approximation, 45.2, 45.2. Why? Because in Poisson distribution, expectation of X is lambda, so is the variance of X. So therefore, now you have to calculate the probability of more than 60. Probability X greater than 60. Do continuity correction. Number line, mark 60, mark 60.5 and mark 59.5. Now there are two options. The first option is this one. The second option is this one, which is the correct one. Since 60 is non-inclusive, so after continuity correction, this becomes probability X is greater than 60.5. So when we do X is greater than 60.5, it's back to the basics. That is probability Z is greater than 60.5 minus 45.2 divided by square root of 45.2, and then knowledge of S1 is assumed. So now I have this way of saying that whenever we do the working, this knowledge of S1 is assumed. That means you're back to the basics of reading the table. Let's move to the next question. That is question number 3. It says a random sample of 75 students. So let me highlight this and also let me write it in the first one. That was basically about sampling. So first one is sampling. Second one is Poisson. Third one, let's see what it is. It says a random sample of 75 students at a large college was selected for a survey. 15 students said they owned a car. From this result an approximate alpha % confidence interval for the proportion of all students at the college who own a car was calculated. So proportion is basically about own a car. The width of this interval was found to be 0.162. Calculate the value of alpha, correct to two significant figures. This question is about confidence interval for population proportion. Now let's go back and revise what is there in this concept. Basically, they are the first formula, that is PS, proportion of success, plus minus Z, square root PS QS over N. PS is proportion of success. What is in this case? We'll see it in a short while. QS is proportion of failure, N is the number of sample, and Z is that a value that you get it from the percentage. The other formula is for width, that is 2Z square root PS QS over N. So now PS is 15 over 75, which simplifies to 0.2. Therefore, QS is 1 minus PS, which is 0.8. N is 75. Z is what you are looking for because alpha % is unknown. So we need to calculate alpha. And now we would use the width formula. So the width is 2Z square root PS QS over N. Width is 0.162. This is 2 multiplied by Z multiplied by square root 0.2 into 0.8 divided by 75. Now we do the necessary calculation and let's see what value of Z do we get. So we get the value of Z as 1.754. Now let me go to the normal distribution table, and this is the normal distribution table, and let me clear anything that is here from before, and the Z is 1.754. so let me locate 1.754. so 1.754 is 1.7 and then a 5 and then a 4, so 1 2 3 4. So this is 9599 plus 4. So 1.75 and then a 4. So this is what you get, 9599 plus 4. So let me go back to this thing. So the percentage that we get, irrespective of whether it's greater, lesser, that we will calculate a little bit later. So 9599 plus 4 without the decimal. So this becomes 9603. Let me just say that this is 96%. Now let me draw a number line again. When we do the confidence interval thing, let me first bring in the normal distribution table. And what happens is that we have a symmetric confidence interval. That means this Z value is 1.754 and this Z value has to be negative 1.754. So if this is 96% to the left, therefore to the right it's 4%. So this is 4%. Similarly, because of symmetry, this is 4%. Therefore, this is alpha percent. So alpha plus 4 is 100. Therefore, alpha is 92%, correct to two significant figures. So the confidence interval in this scenario was 92%. Let's move to question number 4. So question number 4 is about CRV, and it says a random variable x has a PDF given by such and such. It's a quadratic function and it lies between 0 and 3. First thing, find the probability x is lesser than 1.2. So that's a straightforward thing. So we'll say probability x is lesser than 1.2. So 1.2 is the lower limit, 3 is the upper limit, 1 over 18 goes on the outside, function is 9 minus x squared dx. That's 1 over 18. This is 9x minus x cube over 3, between the limits 1.2 and 3. Now it's between u and the calculator, that is 9 into 3 minus 3 cube over 3, and this is 9 into 1.2 minus 1.2 cube over 3, and then you evaluate it and you get this answer for probability. So that is the working for this particular part. Now let's talk about expectation, and there is one thing that people start taking for granted. That is, we know that when we talk about a graph of PDF in which there is symmetry, so expectation of x is midpoint of the roots. So this is roots, midpoints of sum of roots. Now that is true if the range of x includes symmetry. What does it mean? What it means is that in our case, the limits are 0 to 3. First of all, even before that, for example, if I have 1 over 18, 9 minus x squared, and this is 1 over 18, 3 minus x, 3 plus x. Now, for example, let's say if this function had a range of values of x between -3 and +3. So therefore, this graph would be like this. This is the x-axis. This is the curve upside down. And this is -3. And this is +3. So since there is symmetry and the graph only lies between these two values, so let me just erase this thing. And let me erase this thing. So therefore, in this scenario, this mid value, this would be the expectation of x. But that's not the case. This is if the range was between -3 and 3. But now the range is between 0 and 3. So it's just a little bit of the graph. It's between 0 and 3. So therefore, expectation of x does not equal to 0 because there is no symmetry in this one. Why? Because there is no symmetry. So this is the usual case that we do. I'll just write it down. Expectation of x is x multiplied by the function, which is 9 minus x squared dx. 1 over 18 is on the outside, and the complete limits are 0 to 3. So there is no symmetry. Therefore, this concept is not valid. So therefore, this is 1 over 18 between the limits 9x minus x cubed dx. Now integrate 1 over 18, 9x square over 2 minus x power 4 over 4 between the limits 0 and 3, and that will be the value for expectation of x. Now the third thing, the median of x is denoted by m. Show that this thing is true. The rule for median is probability x less than m is 0.5. That means 1 over 18 is on the outside, lower limit is 0, upper limit is m, and the function is 9 minus x squared dx equals to 0.5. This becomes 9x minus x cube over 3 between the limits 0 and m equals to 0.5. 1 over 18 as it is, or let me just take 1 over 18 to the other side. So that is 0.5 multiplied by 18. This is 9m minus m cube over 3. And when I plug in 0, this is 0 minus 0. So therefore, 9m, this first of all comes out to be 9. And 9m minus m cube over 3 equals to 9. Therefore, multiply by 3. 9 into 3 is 27m minus m cube equals to 27. Therefore, m cube minus 27m plus 27 equals to 0. Let me double check. M cube minus 27m plus 27 equals to 0. We don't have to solve it. You just have to form the equation. So the question is easily done. So 4 questions down. Question number 5. What is question number 5 all about? It says the proportion of people having a particular medical condition is 1 in 100,000. A random sample of 2,500 people is obtained. The number of people in the sample having this condition is denoted by X. State with a justification a suitable approximating distribution for X, giving the values of any parameters. Use this approximating distribution to calculate probability X is greater than 0. Let me read further. The percentage of people having a different medical condition is thought to be 30%. A researcher suspects that the true percentage is less than 30. So this is suspects, this is hypothesis. In a medical trial, a random sample of 25 people was selected. 4 people were found to have this condition. Use a binomial distribution. Test the researcher's suspicion at the 2% significance level. So now this part of the question, this is binomial and it's a hypothesis test. And the first part, it's binomial, but it's going to be converted into most probably a Poisson distribution question. N is 2500. X follows a binomial distribution 2500 multiplied by 1 over 100,000. Expectation of X is NP, that is 2500 into 1 over 100,000. 1, 2, 3, 4, 5, that's all good. So these two zeros and these two zeros disappear, and then it is 0.25 and 0.025. So expectation of X is coming out to be 0.025. That is the first thing that you get. So therefore this is 0.025. What is the justification? Since n is greater than or equal to 50 and NP is lesser than 5, therefore X follows a Poisson distribution with 0.025. So that is how you convert it. And now you have to calculate probability X is greater than 0. So this is 0 and this is 1 and this is 2 and this is going till infinity. So probability X is greater than 0 is basically probability X is greater than or equal to 1. So this is probability X is greater than or equal to 1. So that is 1 minus probability X is equals to 0, 1 minus e raised to power of negative 0.025, and then you evaluate and you get this answer. Now let's go to the percentage part, the hypothesis part. It says you have to do the whole working for 5 marks. First of all, X follows a binomial distribution and N is 28 in this scenario. Probability of success is 0.30. Sample value, which by default is inclusive, that is 4. H naught P is equals to 30%. H1 P is lesser than 30%. And we are carrying out a test at the 2% significance level. This is the inequality in which we have to carry out the calculation. Probability X is lesser than or equal to 4. Using the binomial formula, 28C0, that's the first one, 28C1 and 28C2. and 28C3 and 28C4. And last but not the least, that is 28C4. So 5-term calculation is what you are supposed to do. This is 0.3 all the way, and this one is 0.7. And what are you calculating? The summation of all these. So this is 0, 1, 2, 3, 4, and this is 28, 27, 26, 25, 24. Now it's between you and the calculator. You add it all up. This comes out to be 0.0474 or 4.74%. Always convert it into a percentage because you would be comparing it with the significance level in percentage. Now the rule is, if the P calculated value is lesser than significance level, then reject H naught. 4.74%, is it lesser than 2%? Definitely not. So therefore, what's the conclusion? Do not reject H naught, accept H naught. So there is insufficient evidence. And what was the question about? It was the researcher suspects. So insufficient evidence to support researchers' suspicion. So we cannot actually endorse this thing. So insufficient evidence to support, endorse, accept researchers' claim. So this question is also done. Now after question 5, this is question number 6. The random variable t denotes the time in seconds for 100-meter races run by Tanya. T is normally distributed. Now this time it's normally distributed. A random sample of 40 races run by Tanya gave the following results. Calculate unbiased estimates of mean and variance. Let's first talk about T bar. That is sigma T over N, which is 560 divided by 4. So that is 140. So that is the mean of Tanya's data. That is the first thing. Unbiased estimate of population mean is the same thing as sample mean. So therefore this is 140. Now in this scenario, normal distribution is already there. But since we are extracting data from sample, so therefore unbiased estimate of population variance is needed for further calculation. That is a must, irrespective of whether it was normal or not so normal. So therefore S square is sigma T square over N minus T bar square. So this is 7850 over 40 minus 140. Actually, sorry, this is 40, not 4. This is 40. So therefore the 0 disappears, and over here the 0 disappears. So this is 14 square, and then unbiased estimate of population variance, it's N over N minus 1 sample variance, that is 40 over 39 into whatever this value is, and then at the end what you get is 25641. So this is 25641, but for this part the answer would be 256 correct to 3 significant figures. Now let's move on. The same question is continuing. The random variable S denotes the time for 100-meter race run by Suki. S has the independent distribution such and such. So there are two persons. Suki, she follows a normal distribution 14.2, 0.3. And this person Tanya, we have to get this data from the first one. So for Tanya, the mean is 14. That is what we calculated. And the variance is 0.256 and 2564. So let's use this. Now this is a question about linear combination. Use your answer to part 2. Find the probability in a randomly chosen 100-meter race. So I mean it's still for a 100-meter race, that's constant. Suki's time will be at least 0.1 seconds more than Tanya's time. So first of all, Suki's time minus Tanya time would be greater than or equal to 0.1. So that is the working that we'll do. So now let me write this thing as let W equals to S minus T. W follows a normal distribution. The means are subtracted, but the variances are added. So these are the means, 14 and 14.2. When you subtract, so this is S minus T. So it's going this way. So 14.2 minus 14 is 0.2. And what happens to the variances? The variances add up. So this is 0.5564. So that is what you get, 5564. So now you have to calculate probability W is greater than or equal to 0.1, probability Z is greater than or equal to 0.1 minus 0.2 divided by square root of 0.5564, and knowledge of S1 is assumed, and then you will get this particular answer. So that is question number 6 done and dusted. Here comes question number 7. The masses in grams from a certain farm have a mean mu and standard deviation 5.2. So the mean is mu and standard deviation is 5.2. The farmer says the value of mu is 64.6. A quality control inspector claims that the value of mu is actually less than 64.6. So it looks like a lower tail test. So now it's about claims and suspicion. In order to test his claim, he chooses a random sample of 100 apples from the farm. The mean mass of 100 apples is found to be 63.5. Carry out the test at the 2.5% significance level. So the first thing over here, that it is about a hypothesis test, and this is for normal distribution. Now whether it's normal or whether it's approximately normal, let's see. That is the first thing. Does it say it follows a normal distribution? I don't think so. So first of all, I'll say since sample is large, n is greater than or equal to 30, so it means sample is large. Therefore, x bar follows a normal distribution. This is 64.6 and this is 5.2 square divided by 100, where n, the value of n is 100. That's the first thing. Second thing is that it's at the sample mean. That's the second thing that you should state. The sample mean is 63.5. H naught mu is 64.6. H1 mu is lesser than 64.6. And what else is there? It's at the 2.5% significance level. Now for 2.5% significance level, the Z value is 1.96. So it's a lower tail test. And let me mark it over here. So this is 2.5% significance level. This is 0. This is negative 1.96. I've already prepared the table for you. Now what calculation is there? Simply calculate the Z value. So Z is 63.5 minus 64.6 divided by square root of 5.2 square over 100. 5.2 square over 100. And this Z value comes out to be negative naturally, because 63.5 is lesser than 64.6. This is negative 2.115. Now, does this value, the calculated Z value, does it lie inside the critical region? Yes, it does lie inside the critical region. What is the conclusion? Reject H0, accept H1. What is acceptance of H1? Acceptance of H1 is claims that the value of mu is actually less than 64.6, and that's the quality control inspector. So yes, there is sufficient evidence to support or believe the quality control inspector claim. So that is the working for this one, and there is sufficient evidence. Now let's see what the next page says. The next page says, Later, another test of the same hypothesis at the 2.5% significance level with another random sample of 100 apples is carried out. Given that the value of mu is in fact 62.7, so there is a new value for mu. That means the question is about probability of type 2 error. Now, type 1 error and type 2 error has to occur in pair. What's the logic for this one? The logic is whatever inequality that you have for type 1, it's basically flipping of this inequality. So first of all, let me label this percentage again. That is 2.5%. This is negative 1.96. And I am actually looking for the corresponding value for this negative 1.96. So z is x bar minus mu sigma square over n under root. Z is negative 1.96, x bar, that's the boundary condition. This is the previous value, which is 64.6. So therefore, that is 64.6 and divided by 5.2 square over 100 square root. Now let me grab my calculator. That is 5.2 over 10, which is 0.52, and 0.52 into 1.96. So 1.96 into 0.52, this comes out to be 1.0192 with a negative sign. That is x bar minus 64.6. 64.6. Therefore, the value of x bar is minus 64.6. This comes out to be 63.5808. 63.5808. This is the boundary condition for this one. That means if x bar is lesser than 63.5808, lesser or lesser than or equal, doesn't make much of a difference, then we will reject H naught. In other words, if x bar is greater than 63.5808, we would accept H naught. Now, what else is there? The concept is probability of type 2 given a new value of mu, which is 62.7. That is flipping of this inequality. Why? Because accept H naught when H naught is false. That is the definition of type 2 error. Let me write it. Type 2. Accept H naught when H naught is false. When H naught is false, H1 is true. That is why they have to give you a new value. So therefore, probability x bar greater than 63.5808. The same calculation, the same type of calculation is there, not the same calculation, but with a different number. So therefore, probability z is greater than 63.5808 minus 62.7. Everything else is the same. That is 52.2. That is 5.2, not 52.2, 5.2. Square over 100 square root. Probability z is greater than 1.694. Therefore, 1 minus 5 of 1.694. You go to the table, you do the subtraction, and this comes out to be 4.51%. That is the probability of type 2 error. So that's how this question is done. And now let me go to the examiner report. So let's start from the first thing. The whole paper was done. This is November 2021, variant 61. Key messages. For questions that require several probability terms, it is necessary to show all the terms in full. That means do not skip any working. In question 5b, it was necessary to write down all the required binomial terms. Now, some people, they think that they can do everything in the calculator, then it will be the calculator giving them the grade rather than the examiner. Final answers are generally required to be given to 3 significant figures unless otherwise stated. So, final answers generally 3SF unless otherwise specified in a question. Candidates are reminded to ensure that they round their final answer appropriately, ensuring that the significant accuracy is root rather than decimal places. To ensure the accuracy of the final answer, it is important that candidates maintain a forced significant accuracy throughout the working. So now the same kind of working is there. That was there in P1 and P3 and M1 and S1 and S2. Everything, it's the same thing. Show all working. Now comments on specific questions. The requested probability. Now the first one was about this thing, that was sampling. There is nothing special in this one except that the diagram could help the candidates with this if someone is not very familiar with the rules, so the diagram would help. Question number 2 was that Poisson was the normal approximation to find the probability continuity correction. That was the first thing. Many candidates applied this correctly. Candidates needed to subtract the corresponding value of z. That means that knowledge of S1 is assumed. You have to do it correctly. Question number 3, what was that about? That was that confidence interval width. And they found the value of sigma and 2 significant figures. Some candidates only found the z value and they wrote this answer. That is, they did not take care of symmetry. So symmetry was there, number line was there. Question number 4, to find the probability, it was necessary to integrate between the limits 0 and 2. It was essential to clearly write down the integration itself. A few candidates used the wrong limits and such and such. To find expectation of x, it was necessary to integrate x f x between the limits 0 and 3. Integration showing is a must. And part 3, it was necessary to integrate between the limits 0 and m and then equate the result to 0.5, and that was pretty straightforward. Question number 5 was about the suitable approximating distribution for the binomial was the Poisson distribution with parameters such and such, which could be expressed as this. The justification involved the value of the sample size and the value of NP. N is greater than this and NP is lesser than this. Critical values 50 and 5. Many candidates did not complete the justification fully. Many candidates answered this question by finding such and such the required 3 significant figures and not just 3 decimal places. Now people mix up the two. The accuracy level is 3 SF, not 3 DP. The significance test required the hypothesis to be stated always, the relevant probability to be found, the comparison to be shown, and the conclusion to be stated. Read it again. The thing is, hypothesis to be stated, H0, H1, relevant probability to be found, comparison to be shown, conclusion to be stated. A one-tailed test was appropriate, required probability was found using binomial. It was necessary to write down all the binomial terms. Now people try to skip this. Some candidates only found this value and such as such. From the wording of the question, let me underline this. From the wording of the question, the context could refer to the researcher's suspicion or to the percentage of the people having the medical condition being less than 30%. That means when you say accept H0 or reject H0, so write the answer properly in the context of this question. Question number 6. Most candidates found the unbiased estimates correctly, showing the substitution. It was necessary to create a new variable such as S minus T and then compare with 0.1 second, and the rest is nothing else. Question number 7. Necessary to use the normal distribution by sample mean. The mean mass, the sample of 100 apples could then be standardized, the comparison with the significance level, and the conclusion made. The hypothesis was needed for one-tail test. Critical Z value was 1.96. Comparison using this and using the corresponding probabilities, these values indicate a significant result. Many candidates follow the steps correctly, produce a correct conclusion. The conclusion needed to be stated in the context of the question in a non-definite form with no contradictions. That means sometimes people write sentences which makes no sense. They are self-contradicting. Some candidates lost some accuracy in the final answer, rounding prematurely, particularly when changing the probability approach. We don't have to do the probability approach. Z method is the best. And to find the probability of type 2 error, it was necessary to find the acceptance region of H0 using the normal distribution. The value can then be used in the normal distribution, such and such. A few candidates completed this work successfully, and we are one of them. Many candidates did not find the acceptance region and attempted only the second part. Of course, they would lose the credit. And two diagrams or a combined diagram could be helpful. So this is if needed, then only we will do it. So that finishes November 2021 variant 61 of the S2 paper. Stay tuned for more.